to Projects. In this video, we are going to explain about the project, which is privacy preserving data mining framework for negative association rules and application to healthcare informatics. Coming to the introduction of the project, the problem being addressed in this project is the prediction of different types of diseases, specifically breast cancer, heart disease, diabetes, and iris classification. These diseases have significant impacts on individuals' health and well being, so early detection and prediction are crucial for timely treatment and management. The goal of this project is to develop machine learning models that are capable of accurately predicting the presence of these diseases based on diverse input features. By leveraging datasets containing patients' medical history, symptoms, and other relevant factors, these models aim to assist healthcare professionals in diagnosing and managing these conditions. Conventional disease prediction methods often involve manual analysis by healthcare professionals, which can be time consuming, subjective, and prone to errors. Moreover, these methods may not consider all the pertinent factors or detect complex patterns in the data. Additionally, traditional approaches may struggle with the handling large data sets and intricate relationships between variables. The proposed system utilizes machine learning techniques like logistic regression, KNN, and Naive Bayes to automate disease prediction. By analyzing extensive data sets, it uncovers patterns not easily discernible manually. Feature selection enhances model accuracy and interpretability. Integrated into a unified framework with advanced data pre-processing and evaluation tools, the system aims to overcome traditional method limitations and develop accurate disease prediction models. Coming to the objective of the project, the objective of the project is to develop machine learning models that are capable of accurately predicting the presence of various diseases, including breast cancer, heart disease, diabetes, and iris classification, with the aim of enabling early detection and timely treatment. The goal is to leverage logistic regression, k-nearest neighbors, which is KNN, and naive-based algorithms for disease prediction, harnessing their capabilities in handling diverse data sets and uncovering complex patterns. The aim is to predict the presence or absence of the breast cancer, heart disease, and diabetes, as well as classifying iris flowers into different species based on their characteristics. The objective includes comparing the performance of developed models using evaluation metrics such as accuracy, precision, recall, and FN score to assess their effectiveness and reliability in disease prediction tasks. The project aims to benefit healthcare professionals, patients, and healthcare organizations by providing access to accurate disease prediction models, facilitating early diagnosis, personalized treatment planning, and efficient resource allocation. To implement this project, we need software and hardware requirements. Coming to the software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to the hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. So coming to the first step, which is importing the packages, this step involves importing necessary Python libraries and packages into the project environment. We have imported NumPy and Pandas for data manipulation, scikit-learn for machine learning, Seaborn and Matplotlib for visualization, and other required libraries for data analysis and model development. The next step is importing the dataset. In this step, datasets related to different diseases, which are breast cancer, heart disease, diabetic dataset, and iris dataset, are imported into the project environment. These datasets serve as a foundation for building predictive models. Each dataset contains relevant information of the patients. Coming to the next step, which is exploratory data analysis. EDA involves exploring and analyzing the data sets to understand their structure, distribution, and relationships between variables. This step helps in identifying patterns, trends, and outliers and potential issues in the data, guiding subsequent data pre-processing and modeling steps. The next step is data visualization. Data visualization techniques such as histograms, scatter plots, heat maps are employed to visually represent datasets characteristics. Visualization aids in gaining insights into the data, identifying patterns, and communicating findings effectively. The next step is feature selection. Feature selection is carried out in this step to select the most relevant features from the dataset. This process aims to improve model performance and reduce overfitting. The next step is K-anonymization. K-anonymization is a privacy-preserving technique which is applied in this step to anonymize sensitive data. This involves grouping individuals into clusters with at least k other individuals sharing similar characters. K anonymization helps protecting individuals' privacy while still allowing for meaningful analysis and modeling of the data. The next step is splitting the data into train and test. The dataset is divided into two subsets, which is the training set and the testing set. In this step, the training set is used to train the machine learning models, while the testing set is used to evaluate their performance on the unseen data. This step ensures that the model performance generalizes well to new and unseen instances. The next step is building the models. In this step, machine learning models such as logistic regression, KNN, naive Bayes are initiated and constructed. Each model aims to predict the presence of the target disease based on input features from the dataset. The next step is training the models. The constructed model are trained using the training data to learn the underlying patterns and relationship between variables, input features, and the target variable. During training, models parameters are adjusted iteratively to minimize the prediction error on the training data. The next step is Flask framework with SQLite for sign up and sign in. The Flask framework is used to develop a web application for user interaction. SQLite is employed as a lightweight database to store user account information for sign up and sign in functionalities. This allows users to create and access accounts securely, providing a user friendly interface for inputting data and obtaining predictions. The next step is user gives input. User provide relevant information into the web application interface during this step. This input serves as a basis for predicting presence of the target disease using the trained machine learning models. Coming to the next step, which is given input is pre-processed with the trained model. The input provided by the user is pre-processed to ensure consistency and compatibility with the trained machine learning model. Pre-processing involves tasks such as data cleaning, normalization, and feature engineering. The pre-processed input is then fed into the trained machine learning model to predict likelihood of disease presence. The last step is final outcome is displayed. The predicted outcome such as likelihood of the disease presence or the absence is displayed to the user through the web application interface. Algorithms which are used in the project are logistic regression. Logistic regression is a statistical method used for modeling the probability of a binary outcome based on one or more predictor variables. It estimates the probability that a given input belongs to a particular class by fitting a logistic curve to the data. Logistic regression is commonly used in binary classification tasks, making it suitable for predicting the presence or absence of diseases like breast cancer, heart disease, and diabetes. It is particularly useful when the relationship between the input features and the target variable is linear, or it can be approximated as linear. Coming to KNN, which is K nearest neighbor, KNN is a simple and intuitive algorithm used for both classification and regression tasks. It makes the predictions based on the majority class of its K nearest neighbors in the feature space. KNN is used in the project for its simplicity and effectiveness in handling classification tasks. It can capture complex patterns in the data and does not require assumptions about the underlying data distributions. KNN is suitable for disease prediction tasks where similar classes are likely to have similar outcomes, such as identifying similar patterns with similar disease profiles. The last algorithm is naive Bayes. Naive Bayes is a probabilistic classifier based on Bayes' theorem with an assumption of independence between predictors. It calculates the probability of each class given a set of input features and select the class with the largest, highest probability as a prediction. Naive Bayes is used in the project due to its simplicity, efficiency, and effectiveness in handling high-dimensional datasets. It performs well even with the limited training data, and it is robust to irrelevant features. Naive Bayes is suitable for disease prediction tasks where the independence assumption holds reasonably well among the input features, such as predicting the presence or absence of diseases based on medical history and symptoms. We have used accuracy, precision, recall, and FN score, which are the performance metrics to evaluate all the models built in the project. So here we have performance comparison graphs for all those metrics. This is accuracy comparison graph, where x-axis represents all the algorithm names and y-axis represents accuracy score for each algorithm. Similarly, we will have for other three graphs also. Coming to accuracy, it is the proportion of correct predictions in a classification task measuring the overall correctness of a model's predictions. This is precision score comparison graph. It is the ratio of true positive predictions to the total positive predictions, representing model's ability to correctly identify all relevant instances while minimizing false positives. This is recall comparison graph. Recall is also known as sensitivity or true positive rate. It is the ratio of true positives to the total actual positives, measuring a model's ability to capture all relevant instances without missing any. This is FN score comparison graph. FN score is the harmonic mean of precision and recall, offering a balanced measure that considers both false positives and false negatives, making it suitable for imbalanced data sets. The algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we have to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. These are the RBYNB files. This is a Jupyter Notebook file which contain a combination of code, graphs, and outputs all in one place. These IPYNB files allow users to write and execute code in individual cells, making it a popular choice for the data science. This is the signup file. This file is a database file used to store the user information. And these are the model files which contain the algorithm information and that will be loaded into the project code during runtime. Now we have to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we have to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This will change current directory to the code folder's path. So here we can observe that current directory is changed to the code folder's path. And here we need to type the command python space app.py to compile app.py file. And now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port, unless configured differently. This is the localhost and this is the port. Now we have to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built using the Flask framework. So first we need to register to execute the project. For that, click on register link. And here we need to enter all the sign up details. After signing up, we have to click on submit button. I have already signed up and have an account in it, so I'll directly log in. Here we need to provide our credentials. So I'm giving the username and the password. And now click on login. I have logged in successfully and I'm redirected to prediction page. As we have already mentioned you that we are going to do prediction for all the types of diseases. First, we'll do heart disease detection. Click on heart disease button. Here we need to enter all these parameters. Based on the given parameters, we will get the prediction that whether heart disease is present or not. Before entering the parameters, first we will understand them. The first one is sex, which means that gender. Coming to the next one, which is CP, which is chest pain type. CP represents the type of chest pain experienced by the patient. The next one is REST ECG, which is resting electrocardiographic results. REST ECG describes the resting electrocardiographic results indicating the presence of abnormalities such as normal ST wave abnormality or left ventricular hypertrophy. The next one is exang, which means that exercise-induced angina. Exang indicates whether the patient experiences exercise-induced angina during physical activity. The next one is CA, which means number of major vessels colored by fluoroscopy. CA represents the number of major vessels colored by fluoroscopy, providing information about the severity of coronary artery disease. The last one is TAL, which is thalassemia. TAL indicates the type of thalassemia present in the patient with the values ranging from 1 to 3 representing different degrees of severity. As we have understood all the parameters, now we will enter them. I entered all the parameters. Now click on submit. Here we got the prediction that the patient is safe, which means that he is not having any heart disease. Now we will try with the other set of parameters. Click on try again. Click on heart disease. I entered all the parameters. Now click on submit. So here we can see that the patient is diagnosed with heart condition, which means that he's having the heart disease. Now we will predict the other disease. So click on try again. Now we will do the prediction of breast cancer disease. So click on breast cancer. So here also similar to heart disease detection, we can see parameters which are need to be entered. Based on the given parameters, we will get the prediction that breast cancer is present or not. Before entering the parameters, we will understand them. The first one is radius mean, which means that it is the average distance from the center to points on the perimeter of the tumor mass. The next one is perimeter mean. It is the average length of the boundary or the outer edge of the tumor mass. The next one is concavity mean. It is the average severity of concave portions of the contour of the tumor mass. The next one is concave points mean. It is the average number of concave portions or dips in the contour of a tumor mass. The next one is symmetry mean. It is the average symmetry of the cell nuclei present in the tumor mass. The next one is texture SE, which is standard error. The standard deviation of a grayscale values in the image of a tumor mass capturing variations in the texture. The next one is perimeter SE, which is perimeter standard error, the standard deviation of the length of the boundary or outer edge of a tumor mass. The next one is concavity SE. Concavity SE is concavity standard error. It is the standard deviation of a severity of concave portions of the tumor contour tumor mass. The next one is radius worst. Radius worst is the maximum distance from the center to points on the perimeter of tumor mass considering the worst case scenario. The next one is texture worst. The worst or most extreme variation in grayscale values in the image of a tumor mass indicating the most irregular texture. The next one is compactness worst. Compactness worst is the worst case measure of the how compact the shape of a tumor mass is calculated as a ratio of perimeter square to area. Coming to the next one, which is concavity worst, it is the most severe concave portions of the tumor of a tumor mass considering the worst case scenario. The next one is concave points worst. It is the most prominent or numerous concave portions or the dips in the contour of a tumor mass considering the worst case scenario. Next one is symmetry mass. Symmetry mass is the worst case symmetry of the cell nuclei present in a tumor mass indicating the most irregular shape. The last one is fractal dimension worst. It is the worst case measure of the complexity or irregularity of contour of a tumor mass capturing its fractal nature. As we have understood all the parameters, we will enter them. I have entered all the parameters. Now click on submit. Based on the given information, we got the prediction that the patient is diagnosed with benign condition, which means that patient is not having breast cancer. Now we will try with the other set of parameters. Click on try again. As we are doing breast cancer prediction, so click on the same link breast cancer. Now we will enter all these. I entered all the parameters. Now click on submit. So here we got the prediction that patient is diagnosed with malignant condition, which means that patient is suffering from breast cancer. Similarly, we will try detection of other diseases. So click on try again. Now we will do diabetic prediction. So click on diabetic link. Similar to other diseases, here also we have the parameters which are need to be entered. First, we will understand them. So coming to the first parameter, which is pregnancies, it is the number of times a woman has been pregnant, including both full term and miscarried pregnancies. The next one is glucose. It is the concentration of glucose, which is the sugar in the blood, measured in milligrams per deciliter, which serves as a key indicator of blood sugar levels. The next one is BMI, which is body mass index. It is a measure of body fat based on height and weight, calculated by dividing weight in kilograms by the square of height in meters, indicating whether a person is underweight, normal weight, or overweight or obese. The last one is diabetic pedigree function. It is a measure of the diabetes hereditary risk calculated based on the family history of diabetes and other factors, providing an estimate of the likelihood of developing diabetes based on genetics. As we have understood all these parameters, we will enter them. I entered all the parameters. Now click on submit. So here we got the prediction that patient is safe, which means that it is not having any diabetic. Now we will try with the other parameters. So click on try again. As we are doing diabetic prediction, click on diabetic link. We will enter the parameters again. I have entered all the parameters. Now click on submit. So here we got the prediction that patient is diagnosed with diabetic condition, which means that patient is having diabetic disease. Now we will do iris classification. So click on try again. Here click on iris. Here we need to enter petal length centimeters and petal width centimeters. So now we will enter them. I entered the parameters. Now click on submit. So here we got the prediction that iris setosa detected. Now we will try again. Click on try again. Click on iris. I entered the parameters. Now click on submit. So here we got the prediction that iris virginica detected. Now we will try again. Click on try again. Click on iris. Enter the parameters again. I entered the petal length centimeters and petal width centimeters. Now click on submit. So here we got the prediction that iris versicolor detected. Now click on log out. In this way, just by entering the parameters to the system, we will get the disease prediction. Conclusion of the project. The project has successfully developed achieving its objective of creating machine learning models for accurately predicting various diseases, including breast cancer, heart disease, diabetes, and iris classification. These models facilitate early detection and timely treatment, contributing to improved healthcare outcomes. Among the algorithms evaluated in the project, logistic regression emerged as a top performer in terms of predictive accuracy and reliability. Its ability to model the probability of binary outcomes makes it well suited for disease prediction tasks, demonstrating its effectiveness in handling diverse datasets and uncovering complex patterns. Logistic regression, the algorithm that performed well, is deployed in the front end to provide users with accurate disease prediction results. By leveraging the logistic regression model, the front-end application offers users a reliable tool for assessing their risk of various diseases based on input data such as medical history and symptoms. Future prospects include expanding disease coverage, incorporating additional features, and exploring advanced techniques for enhanced accuracy and collaboration with healthcare providers and researchers for clinical deployment.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.